Hi everybody, this is Dr. Nigro with the Chem Calculation Screencast. This one is focused on balancing redox reactions. All right, so that word redox is a compilation of two words. A redox reaction is a look at how electrons move among atoms in a reaction. All right. We've been dealing with all types of reactions in chemistry: single replacement, double replacement, synthesis, decomposition, but we haven't looked specifically at what the electrons are doing at that particular level as these bonds are being broken and new bonds are being formed. That's what redox reaction looks at, is specifically how are the electrons moving amongst our components. All right, so to keep in mind, you have to have two redox reactions. That's where the word comes from. You need to have a reduction and an oxidation. Sorry, fix my spelling. And they must both occur at the same time. All right, so to help us remember that, we have a little mnemonic device we like to use where if an element is losing an electron, then it's undergoing oxidation. And if an element is gaining electrons, it's undergoing reduction. So we write Leo says GR. Right now, there are others out there. There's oil rigs where oxidation is losing or reduction is gaining. I like Leo says GR. That's the one I was taught, and that's the one I tend to use. All right. For the oxidation piece, all right, if you lose electrons, all right, that means the electrons are products in that half reaction. You're undergoing oxidation. All right, so we have an element that is releasing electrons. All right, at the same time, you have a second element undergoing reduction where it is gaining electrons, and electrons are a reactant in that particular reaction. The component that is losing the electrons is causing the reduction. And we call this the reducing agent. All right. The substance that is gaining the electrons, all right, is oxidizing or causing the oxidation of the other element. So it becomes the oxidizing agent. All right, so whatever element's being oxidized is the reducing agent, and whatever element is being reduced is the oxidizing agent. Okay, now we're going to deal specifically with single replacement reactions and looking at the half reactions that are happening there. Obviously, you can have redox reactions with any number of chemical reactions. We just don't have the time this year to deal with the double replacements, although they are really fun. All right, so one thing to keep in mind when you're trying to put together your half reactions, whether it's just for a practice problem or building a galvanic cell, the more active metal tends to lose electrons. So the more active metal tends to be oxidized. All right, and when we talk about cell potentials in a later screencast, all right, we're going to see that holds true. All right, so just as a rule of thumb, when you're looking at particular elements, use your activity series. If your metal is higher than the ion, then the reaction will go, and the more active metal always likes to be the one that gives the electrons. All right, so we're going to try a couple of these single replacement reactions. We're going to do a couple different things. First, we're going to determine if the reaction will occur. And for that, we're going to use our activity series. All right, if you don't have one handy, you can always look one up on Google. There are plenty of them. All right, if the reaction will occur, we're going to predict the products, including the state. So we might use our solubility rules. And remember, some of our metals, particularly our transition metals, can have more than one possible charge. And for this particular activity, you can choose what charge you want it to be. All right, once we write the products, we're going to balance the reaction. Then we're going to write the net ionic. And then from that net ionic, we can split it into the half reactions. All right, the spectator ions, we're going to remove those from our total to get to our net. All right. And then we're going to identify which reactant was the oxidizing agent and which was the reducing agent based on whether something's getting oxidized or reduced. All right, so let's look at what we've got. We've got aluminum plus iron 2 chloride. All right, if I go look at the activity series, I see that aluminum is higher than iron on the activity series. So this reaction will occur, which means the iron is going to get replaced in that compound by aluminum. All right, so we write iron solid and then AlCl3 aqueous. All right, I check for balancing. If I look, oh, my chlorines aren't balanced. So I'm going to need 3 of my iron 2 chlorides and 2 of my aluminum chlorides, which means I'm going to need 2 aluminums and 3 iron. So there's my balanced chemical reaction. All right, now I'm going to write my total ionic so that I can get to my net ionic. All right, so I've got 2 aluminum solid plus 3 Fe plus 2 ions as that iron 2 chloride splits and 6 Cl minus ions. So there's my reactants. On the product side, I've got 3 iron solid plus 2 Al plus 3 aqueous plus 6 Cl minus aqueous. All right, so now I look and see if I have any spectators, and I do. I have Cl minus on both sides of the arrow. So that particular substance, its oxidation number is not changing as part of this reaction, so it is not involved in the transfer of the electrons. All right, now let's see what's left. So we've got aluminum solid plus 3 iron plus 2 ions gives us 3 iron solids plus 2 aluminum plus 3. So to identify my half reactions, I find the substances that are only varied by the electrons, and I connect them, and then I come down below and I rewrite those. All right, so down here, I'll start with aluminum. I've got 2 aluminum atoms and 2 aluminum plus 3 ions. All right, so if I look, aluminum is going from an oxidation number of 0 on the reactant side to an oxidation number of plus 3 on the product side. So its oxidation number went up, which means that it has lost electrons. So this is going to be my oxidation half reaction. To balance for charge, I'm neutral on the reactant side and plus 6 on the product side. So I'm going to need to add 6 electrons to that product side to balance charge. All right, now I have my second half reaction, iron plus, no, not plus 3, sorry, plus 2. Plus 2 yields 3 iron solid. And if I look here, I'm going from an oxidation number of plus 2 to an oxidation number of 0. So I'm dropping my oxidation number, which means it's gaining electrons. So this is going to be my reduction. All right, then to balance for charge, I have a neutral charge on my product side and a plus 6 on my reactant. So I'm going to need to have 6 electrons as a reactant, which is what I would expect for a reduction reaction. All right, and if I look, everything looks good, everything's balanced, and my electrons are going to cancel on the 2 sides. So I know I've got the right number. All right, now to identify my agents, all right, aluminum is being oxidized, so my reducing agent is going to be solid aluminum. All right, the iron ion is being reduced, so my oxidizing agent is going to be iron plus 2. All right, and then those are my agents. Okay, so that's what we need to do. All right, so let's try another one. All right, this time I've got chromium and silver nitrate. All right, so again, I go check the activity series, and chromium is higher in the activity series than silver, so it is able to replace silver. So one of my products will be Ag solid. All right, chromium can be plus 2 or plus 3. I'm just going to use the plus 2 version, so chromium nitrate aqueous. All right, then I'm going to balance. I'm going to need 2 silver nitrates to balance my nitrate and 2 silvers to balance my silver. All right, now it's time for my net ionic. So I've got solid chromium plus 2 silver ions plus 2 nitrate ions yields 2 silver metal plus chromium plus 2 aqueous plus 2 nitrates aqueous. All right, so there's my full ionic. If I check for spectators, I see 2 nitrates on each side, so those are going to go. And then I've got chromium metal and chromium ions, and then silver ions and silver metal for my two half reactions. All right, so I'm going to pull those apart. I'll start with my chromium solid, goes to chromium +2 aqueous. All right, and again, we can see that the oxidation number for chromium has gone up as part of this process, which makes this my oxidation. And to balance for charge, I need to add 2 electrons to my product side to make it neutral on both sides. All right, for my reduction, I'm going to have silver ions, 2 of them, and 2 silver metal atoms. All right, and you can see your oxidation number is going down from +1 to 0, so that is my reduction. All right, and I'm going to need 2 electrons on my reactant side this time to balance for charge. All right, and just like we saw earlier, those 2 electrons would cancel, and we work our way back to the net ionic equation. All right, so when it comes to our agents, chromium metal is being oxidized, which makes it the reducing agent. All right, and then silver ions are being reduced, which makes them my oxidizing agents. All right, so there are the agents. All right, one more. All right, this one's a little bit different because it involves hydrogen. All right, but I didn't want you to forget about hydrogen as part of our activity series. All right, if we look, zinc is above hydrogen in that activity series, so this reaction is going to go. All right, so I'm going to form hydrogen gas, H2 gas, plus zinc chloride, aqueous. Check for balancing. I'm going to need 2 hydrochloric acids, and then that's going to take care of the balancing. All right, now we split into ions. We have zinc solid plus 2H plus, aqueous, plus 2Cl minus, aqueous, forms H2 gas plus zinc plus 2 ions and 2Cl minus ions. All right, so I check for spectators and I see Cl minus, whoops, that's not what I meant to do. Cl minus on either side, so that must be a spectator. All right, and then I put together my pairs, and I have zinc metal interacting with zinc ions, hydrogen ions, and hydrogen gas. All right, so I'm going to split those into my 2 half reactions. I'll start with zinc. So I've got zinc solid and zinc plus 2 aqueous. And if I look, again, my oxidation number is going up. So that means it's losing electrons. So this is my oxidation. To balance for charge, I'm going to need to add 2 electrons to that product side. All right, for my hydrogen ions, they're going to form hydrogen gas. All right, and my oxidation number has gone from +1 to 0, so it's gone down. This is my reduction. And I'm going to need 2 electrons on my reactant side to balance. And then when I check, those 2 electrons are the same on each side, so they're going to balance. For my agents, zinc metal is being oxidized, so that makes it my reducing agent. And H plus is being reduced, so that makes it my oxidizing agent. All right, and there we go. Okay, so again, when you're working these single replacement reactions, you got to start by determining if the reaction is going to happen. So use your activity series. If it will, predict your products, including the state. And if your metal has more than one possible charge, your transition metals, you get to choose what you want its charge to be. Then balance correctly. Write your net ionic equations, ignore your spectator ions, and then split into half reactions. Balance for charge and identify your oxidation and reduction so you can find your oxidizing agent and your reducing agent. Okay?